This is the physics cannon, okay? This is a 2.5-inch diameter, it is a conduit, electrical conduit, so if you ever need to replace it, right? A tennis ball will fit very snugly in the end of this, okay? So you're gonna push that tennis ball, and I'm not gonna do that, right? And then there's a ramrod, that's what this thing is for, okay? It's a 10-foot pole or something like that, right? And what you wanna do is you basically wanna push the cannonball in until it's about there, okay? Right about there, sort of the end of that cart there, right? So you just push the cannonball in here, right? You get some kid to help you, you know, okay? And then you gotta open up the breech. And in the breech, I don't know if you can see that on the video, there's a couple wires I've stuck in there, okay? And they almost touch each other, and so that's what you're gonna hit with the Tesla coil, right? So the way to operate this is you've got methanol, right? You spray the methanol in there, tip it up like this, right? Well, first put the cannonball in, right? Then spray the methanol in there. Then you put the breech in, like this. And then I just put there, you can see the little metal things that come out. I put one of those up like that. And then I use this Tesla coil, right? Get it sparking, like make sure it's sparking, right? And then I go on your mark, get set, boom, like that, and off it goes. On the other side, I'll put a bunch of cardboard boxes to sort of slow it down and stop it. Ultimately, it's good to put like a trash can over there because it can go really, really fast, right? But the point of this is that this, when the cannonball fires off, this thing recoils, and we can measure how far it recoils. I've got a long tape measure, right? So you measure how far it recoils. You measure the time it takes to stop, and now you have the final velocity is 0. You've got the time it took to stop, and you've got the distance it went. So those 3 things you can calculate the initial velocity. This is 7.56 kilograms. I wrote that on the card itself, okay? And then you can mass the tennis ball, right? Put it on a scale and mass it, and then you know you can use conservation of momentum to calculate the speed that the tennis ball is going. And I always have the kids pull out a sheet of paper and write Cannon Lab on there. And you can make it extra credit, or you can make it credit, or you could just do the calculation yourself. Just a word of safety. I kind of got in trouble for having a kid carry a box that was on fire outside, so strictly off limits, kid. You know. But I have a kid watch the boxes, and they have to say, "My heavens, Mr. Murray, the target box appears to be on fire." You know. But anyway, yeah, you know, so have some kid just monitor stuff, right? The tennis ball can be on fire after it comes out, and so it's always good to have like a wet towel or something to throw over it. It's loud, so I do warn the other faculty that are in the hall. I'll say, "Hey, we're going to fire off a cannon like that," because it can be pretty loud and thumpy. And you could do this. I've done it just in the hall outside, but you can also do it like, you know, at the senior hall or something like that. It's kind of fun. I mean, you know, there's, at least these days, there's 1 million kids in the hall, so it's kind of entertainment for them too. I don't think there's anything else I need to say about this. Enjoy.